Hello everyone. In this video, we will learn about the second case where one stress is tensile and the other is compressive. And in comparison, in the first case, this we had this kind of things in front of us. Okay, so in this case, both the stresses were tensile and unequal. So we have discussed about that in the part one. So now we are going to move forward to the second one. So in this case, one stress is tensile, that is sigma 1, it is a tensile stress, and sigma 2 is the compressive stress. That's why we take a negative sign before that. So for that, the radius of the Mohr circle is going to be, it is basically the radius of the Mohr circle is basically sigma 1 minus sigma 2 over 2 in case of that in case where both of the stresses are tensile, but in this case sigma 2 is compressive, right? So in this case we need a negative sign before sigma 2, so minus sigma 2 and here it is a minus, so it will be plus. So sigma 1 plus sigma 2 over 2. So this is a changed formula in case of a where if one stress tensile and the other is compressive. In case of that, if you want to find the normal tangential resultant and phi, so in this case you will use this formula for finding out the radius. So here I have taken sigma 1 as 200 Newton per millimeter square, sigma 2 as negative 100 millimeter per square. So from this equation, by seeing that sigma 2 is negative 100 and you can see that this is less than that of sigma 1, so sigma 1 will create the major stress axis while sigma 2 is going to create that minor stress axis, and the angle, that is theta equal to 30 degree, is given with the minor stress axis already. You can see from here that the angle is given with the minor stress axis. If it would have been given with the major stress axis, this is the thing that you need to do. You need to subtract that angle from 90 degree in order to find the angle to work with in the Mohr circle. But here it is no longer needed because the angle is already given with the minor stress axis. So now I am letting that 1 centimeter is equals to 20 Newton per millimeter square. So my sigma 1 will become 10 centimeter and sigma 2 will become 5 centimeter. How? Because 200 will be divided by 20, because 1 centimeter is equals to 20 Newton per millimeter square. This is my assumption. You can take it 10, you can take it 30 as you wish. Take it conveniently so that you can use it easily. So now you have got sigma 1 and sigma 2. So now I am going to put those values here. Okay, so this is your center line. Okay, this is my center line. Suppose this is my reference to point. So this is point A. Okay, this is point A, and from point A I have drawn a line that is 10 centimeter long to the positive x-axis. Got my point? And then because 5 is negative, so I need to draw it to the negative x-axis. So from this point, suppose this is your origin point, so this is 0, 0. So from this point, this line you can see that has been marked, this is 5 centimeter line. So AB line is the line that I have drawn for the representation of that compressive stress. Okay, so now what I'm required to do? Now I'm required to find the radius of that circle. So the circle radius is simply sigma 1 plus sigma 2 over 2. So if you just calculate it, so sigma 1 is what? In this case 10, sigma 2 is negative 5. So you just take the value in case. So sigma 1 plus sigma 2 is 15 over 2, that is 7.5. So I need the value from here to somewhere here, that will be 7.5. So let's calculate that. So you will just take your scale here and then you will measure 7.5 distance and you will mark it. Okay, so I am just marking it. So you will mark it 7.5. So I'm taking it 7.5. Okay, so I have got the 7.5 mark, and of course this is my center for the circle radius, center for the circle. Okay, so now I am drawing the circle. So from this point I'm going to draw the circle. So the circle is going to look like this. Okay, so this is my circle which is having the radius 7.5, or you can say the diameter is 15. So now the work is very simple. Okay, so take your pencil here, mark a line from here to here. Don't directly mark it. At first measure the angle. What is going to be your angle? You need to recall it. You need to recall, if you, then the angle is going to be 2 theta. If it is given theta, then the angle is 2 theta. So how you are going to represent that? So okay, so this angle is going to be 60 because your given angle with the minor stress axis is 30. So this is definitely going to be 60. Okay, so I have given the angle 60. So now I am taking again my pencil. So now you need to draw a vertical line Okay, so you have drawn a vertical line. Then just draw some other lines, like, from this point to this point. So you understand, sorry, that has not been aligned properly. So I need to draw a line from this point to this point. Okay, so I have drawn another line, and then I am going to draw a line from this point to this point. Okay, so now you can understand from this circle that this angle is 60 degree. This is from the center. So okay, okay. So because this angle is 60 degree, okay, this angle is here your 60 degree, right? So this angle is going to be 30 degree. So let me take it in front of you to make you understand. So this angle is definitely going to be 30 degrees. So you can see that this angle is 30 degree. Okay. So now you have got this angle 30 degree, this angle 60 degree. So you have got another angle now. This angle is going to be your phi. Okay. This angle is your phi. Okay. Okay. So now you have got this angle, which is your phi. So I am going to write them here. So the angle that you have got, phi, is equals to 46.1 degree. So you will measure this angle using your D in the geometry box. So phi is 46.1 degree. And what is your tangential stress and normal stress? See, take a look at this length. This is your tangential stress. That is 6.49 centimeter. Okay. So I have got the tangential stress as well. So my sigma T is equals to 6.49 centimeter. So with this, I need to multiply that multiplication factor, which was 20. In this case, I assumed that 20. So if I multiply 20 with that, I am gonna end up getting my value for the tangential stress. And from this point to this point, this length you can see, okay, this length you can see 6.25. This is your normal stress line. So sigma n is going to be 6.25 into 20 Newton per millimeter square. And what is going to be sigma r? Sigma r, of course, this triangle, I mean this length is going to be your sigma r. So you need to measure this length by using your scale. So this length is 9.09 or 9.01. So 9.01 times 20 will give you the answer for the resultant stress in this case, okay, Newton per millimeter square. So if you just use the values like I have shown you, sigma 1 and sigma 2 in the actual formula, you will end up getting these values as well, right? So, and if you use the graphical representation method, you will also get the same value. Okay, so with this we end our today's lecture. Thank you very much for watching till the end. Take care. Goodbye.